Taking a look at number 16 from task number 9. Using limit notation, describe the end behavior of the function r of x. So when we talk about end behavior, we're looking to see as it goes to the far left and the far right, what's happening. Is it headed up? Is it headed down? Or is it getting closer and closer to some horizontal value or horizontal line? So in order to do that, we're going to look at the degree of the function. When the degrees are exactly the same as we see with this function r of x, we can say, again, when the degree of the numerator is equivalent to the degree of the denominator, we are able to come up with the horizontal asymptote, which is always y equals, by taking the leading coefficient of the numerator and dividing it by the leading coefficient of the denominator. So I know right now, just based on the patterns, that as we go to the far left and far right, it's going to get closer and closer to this, but I do want to demonstrate that for you. So I took the function r of x and I plugged it in, and this is the function r of x, you can see that. And watch when I actually incorporate into this graph this horizontal asymptote. You can see as it goes to the far right, it's getting closer and closer to the blue line, which is a horizontal asymptote. As it goes to the far left, it's getting closer and closer. Now, as it goes to the far left and far right, it will never cross on the far left and the far right in the horizontal asymptote. It may cross in the middle, as you can see, but on the far ends, it will never. It's just going to get closer and closer. So how do we put this into limit notation? Okay. As we go to the far left for the function r of x, it is approaching the value 3/2. As we go to the far right for the function r of x, it is also approaching 3/2.